Same continuation of Leo constellation concept design and orbits. So we all have challenges whenever we are doing something. So this Leo constellation, the Leo satellite also has a challenge that in terms of a Doppler challenge. So every time a satellite moves over your head or over your UE user equipment, one big challenge for UE is that it has to catch the frequency of that moving satellite. Every time when the satellite is near to the user equipment, it has a strong signals. Whenever it goes far from the user equipment, it has a less stronger signals because it is moving at the 7.5 kilometer per second. So that standard terrestrial, if I see the terrestrial system, it will fail. But so how this Doppler challenge is fixed, that we'll see. Uh, So there are onboarding processing types that are transparent relay, regenerative node, and inter-satellite links. These are mm, basically the connections we'll see. A transparent relay, it is like a simple analog, like it is like a mirror, analog transponder. It will just repeat those RF signals down to the Earth stations. So the satellite acting as a mirror, simple mirror. So it will have a minimal space grade processor load, best for it is a simple relay, and it sits at transparent relay, it will sit at slightly above the regenerative node, Leo. So regenerative node, it will have a working G node be on it. So it will demodulate the signal and it will route the signal to the ground. uh, so it is for high performance. It will regenerative node, it will sit slightly below the transparent relay because for regenerative node we should have a good connectivity or lower RTT, round trip time, because there should be a good connection. But for transparent relay, we should have, it is like transparent relay is a satellite. It is like it acts like a mirror, right? So for these kind of satellite, we can concentrate more on the footprints. Like we can get a good coverage with the help of these transparent relays. So internet satellite links. So these are optical laser mesh between the satellites, so which will route the data across the space nodes in real time. So this inter-satellite link is like the satellites talking to each other. It just saves the time. Okay, it saves the time. Okay, so we have a backhaul latency. First, we need to understand that what is backhaul latency. Without the backhaul connection, even if the user equipment has a good signal connectivity, um, there will be no proper connection. Like it is a connection between the ground station and a core network, 5G core network. So it will just determine the end-to-end latency for all the users. So we have a comparison of terrestrial fiber network, 5 millisecond Leo regenerative, like it sits at 600 kilometer, 12 millisecond is the latency, and Leo transparent, it sits at 1200 kilometer, 26 millisecond is the latency. Geostationary, it has 540 millisecond as the latency. So Leo regenerative, uh, it is competition to the terrestrial fiber network. It is because G node B sits on the satellite, like signal going to the space and coming back, and that latency is competing with the terrestrial fiber. That is a good thing. And Leo transparent has slightly higher latency compared to Leo regenerative because sits above it, and we don't have a working G node before. Like there is no